Lab 1, Electrically Charged Tapes, Valerie Santoso. In this lab, I created a charged tape referred to as the U-tape in order to investigate the effects of charges on other charges and on neutral objects. Then using the momentum principle, I calculated the excess charge on the tape. To understand what was happening and make accurate observations, we had to understand key physics principles such as that like charges repel and opposite charges attract. I also kept in mind the conservation of charges, which states that the overall net charge of the system cannot change. If the charge of a system changes, then the charge of the surroundings must change by an equal and opposite amount. Additionally, there's the momentum principle, which states that the change in momentum is equal to the electric force minus the gravitational force, which can be used to determine the quantity of Q. Overall, I was able to find that the U-tape I created had a positive charge based on the interactions that occurred. The U-tape is created by quickly pulling off the sticky side off another piece of tape, like in the diagram to the right. Once the U-tape was created, I tested the interactions of the U-tape in several scenarios. It's important to note that when conducting the experiment, a lot of precision and carefulness was required to make sure that there are minimal contact with the U-tape with the hands and other objects once it was created. This is because it can become neutralized if it comes in contact with other objects. One of the experiments looked at the interactions between two charged U-tapes, and I found that if you have two U-tapes faced towards each other, they would repel, which in turn indicated they both had like charges. On the other hand, when neutral objects such as my hand, a book, and a cup were held near it, the U-tape moved towards the object. That demonstrated the physics law that a charge will have an attraction with neutral objects. These experiments were used to determine the charge of the U-tape and the magnitude of the excess charge on the tape. To determine the charge of the tape, I created a negatively charged pen by rubbing a pen with a wool cloth and observed that there was an attraction between the pen and the tape. This means that the tape itself had a positive charge. In the final experiment, I placed a charged U-tape labeled B in the figure horizontally, then I took another charged U-tape, tape A, and placed it near tape B. I found that tape B moved upwards and away from tape A, which indicates that they both have positive charges, and like charges repel from one another. By calculating the distance between tape A and tape B and using the momentum principle, I was able to solve for the magnitude of the excess charge on tape A. The data collected goes as follows. The length of the tape was 20 centimeters. The mass was 2 times 10 to the negative 4 kilograms. The change in height of tape B was 0.03175 centimeters. Then using the momentum principle, we know that the change in momentum is equal to 0, which is equal to the magnitude of the net force. The magnitude of the net force on tape B is equal to the electric force from tape A on tape B minus the force of gravity on tape B. Using these relations, we can derive the value of the excess charge to be around 1.4824 times 10 to the negative 8 coulombs. In this experiment, the U-tape had an overall positive charge. But what if the U-tape had a negative charge? Well, if you think about it, the reason that the U-tape had a positive charge was because there were electrons transferred from the top tape to the bottom tape. But if electrons had an overall positive charge instead of a negative charge, then the U-tape would, in result, have a negative charge. This would result in some variations in some of the observations we made. Overall, because two U-tapes that are facing each other would still have the same charge, negative charges, they would still repel from one another. Additionally, any neutral objects would still be attracted to the U-tape, despite it having a negative charge now. But one thing that would change is the observation with the negatively charged rod. Since the U-tape is now negatively charged, and like charges repel, the negative charge rod and the U-tape would repel instead of attract. Lastly, I created a glow script program to simulate the experiment between tape A and tape B and using it to calculate the value of Q, the excess charge on tape A. To do so, I started by defining the constants and initial variables. Then I created spheres to represent the two tapes, the red and blue balls, as point charges. Then I used arrows to represent the gravitational and electric forces. Finally, I created a function called calculating Q and used the derivation from before to obtain the value of Q. Like before, using the simulation, we find that the excess charge on tape A is equivalent to 1.48242 times 10 to the negative 8. When making these calculations, we had to make some basic assumptions, including treating the tape like point charges that is located at the center of the tape. I also assumed that each of the U-tapes created had the same charge distributed evenly along the tape. Lastly, I also assumed that the mass of the tape is equivalent to 1 grams per meter. Using these assumptions and physics concepts, I was able to use the U-tape and find the excess charge on the U-tape that I created.